Okay, so now we're going to go ahead and start on example 3. I would like each of you to take a moment to pause the video and figure out, hey, what should U be? What should DV be? Which of these is easier to take the derivative of and that the derivative will ideally go away completely? And which is easy to take the integral of? So take a moment, think about that. You can pause the video if you need more time. I'm just going to kind of jump right into it here. So my U is going to be X. My dV is going to be e to the X over 2. The reason being that the derivative of U is now 1. Okay, and the integral of e to the x is easy enough. This is e to the x over 2, but there is a problem here. If I took the derivative of this, it would be 1/2 e to the x over 2. I don't want a 1/2. So it's 2 times. Okay. By the way, you could also think about, I'll put this in parentheses here, it's e to the x over 2 divided by 1/2, which is the derivative. Oh no, it got all blurry. I'm so sorry. Okay. When you divide by a fraction, you multiply by its reciprocal. Okay. Nope, U to V equals UV minus the integral of VD. Okay, so let's go ahead and plug all this in here. So the integral of x e to the x over 2 dx equals U is x, V is 2 e to the x over 2. I'm going to go ahead and throw the 2 out in front here. Sorry about that. E to the x over 2. Okay, minus the integral of V, which is 2 e to the x over 2, du, which is literally just 1 dx. Okay, so this is something that I can take the integral of. So I have 2x e to the x over 2 minus, so essentially it's the same thing, I just times this by 2 again, because the 2 e to the x doesn't change. And then I have to divide by 1/2, which is the same thing as timesing by 2. And then I can't forget that plus c. So my final answer here is 2x e to the x over 2 minus 4 e to the x over 2 plus c. And that right there is a dang good answer. All right, let's go ahead and take a look at example 4. This uses a trig function. So we have x sine of x. So once again, okay, all of these are kind of repeating the same pattern here, where u is going to be x. The reason is because I want du to go away. I want it to be gone. All right, dv is going to be sine of x d of x. And v, the integral of this is negative cosine of x. Okay, so now I need uv minus the integral of v du. So I have negative x cosine of x for uv minus the integral of negative cosine x, and then du is just 1 dx. All right, that is easy enough to do. So we got negative x cosine x minus the integral of negative cosine is negative sine. And so minus, oops, sorry, I'm off the screen a bit there, apologize. So minus minus is a plus, gives me a final answer. Maybe I'll put this first just to make it prettier. Sine of x minus x cosine x plus c. Now you could try this out for yourself. When you take the derivative of this, do you get this? And the answer should be yes. Okay, so we can kind of verify that. So the derivative of sine is cosine. So this is just a kind of a fun thing to verify. Cosine x minus, here I gotta use product rule. So derivative of the first is 1 times the second, plus the first times the derivative of the second. That would be, sorry, I'm blanking here. First of all, that should be a minus x. Oh, times negative sine x. And then the c goes away completely.